In the last class, we completed second application of differentiation of first order and subdivision, that is methods of filling. Now in this session, we are learning about the third application, which is law of natural growth or decay. Already we discussed this one in the previous session. So what we discussed in the previous session about this application. So law of natural growth or decay is quantity available at particular time is direct proportional to the rate of change of quantity. So here rate of change of n is the quantity, rate of change of quantity is dN by dt. It is direct proportional to the quantity. This is the definition of law of growth or decay. Here, based on the proportionality, this one is two types. One is law of growth and the other one is law of decay. If time increases, then n increases. This is called law of natural growth. That is dN by dt. Both are in increasing. That means as t increases, n increases. This is called law of growth. That implies dN by dt is equal to k. Here k I take as a positive constant. Already I derived the formula for law of growth. What is the formula? N is equal to c into e power k. Similarly, if time increases, n decreases. That is called law of decay. Similarly, we get into constant. N is equal to c into e power minus k. So here we have to remember these two. When we will use, when we will use. So if as time increases, quantity increases, then we are using law of growth. As time increases, quantity decreases, then we are using law of decay. Small problem related to that. So this. The number n of bacteria in a cultural grow at a proportional to n. So here the number n of a bacteria in a cultural grow at a rate proportional to n. Means n is proportional to dN by dt, which is called law of growth. The value of n was initially 100. Initial means at time t is equal to 0, the quantity value is 100 and is increased to 332 in 1 hour. 332 in 1 hour means 60 minutes. At t is equal to 60 minutes, quantity is 332. Next, what is the value of n after 1.5 hours? I converted hours into minutes. 1.5 hours means 90 minutes. At t is equal to 90 minutes, the value of n we have to calculate. That is, what is the value of n? And we have to calculate. Here, if you are observing that at t is equal to 0, n 100. At t is equal to 60, n 32. So, it is in the increasing way. Increasing means this is called law of growth. And by using law of growth, what is the formula of law of growth? N is equal to c into e power kT. First condition. What is the first condition? At t is equal to 0, quantity is 100. Use this first equation in this. So, t value is 0, n value is 100. T value 0, n value 100. 100 is equal to c into e power k into 0. E power 0 value is 1. So, c is equal to 100. So, I use the first condition. In this, what are the unknowns to this? Here unknowns are c is unknown, k is unknown. If you know these two constant values, at any time, you have to calculate the quantity. Two unknowns means we want two conditions. What are those two conditions? First condition and second condition. By using first condition, I calculate the value of k. Now I will use second condition for the value of k. What is the second condition? At t is equal to 60 minutes, n value is 3. Again substitute in this equation number 1, then this one should be as 6. At t is equal to 60 minutes, n is equal to 3. What is our formula equation 1? N is equal to c into e power k into 3. That implies n value 332 is equal to c into e power k into p value 60. Already you know the value of c, substitute c value here. 100 comes to the left hand side, 332 by 100 e power k into 60 is equal 332 by 100 is 3.32. That implies 60k exponential comes to this side, that becomes as a logarithm. So k is equal, the 60 comes to the right hand side, 1 by 16 into log of 3.32. So here by using second condition, second unknown I calculated. By using first condition I calculated c. By using second condition I calculated k. By using second condition I calculated the value of k. Now what we have to calculate? T is equal to 90 minutes. We have to calculate the value of k. At t is equal to 90 minutes. Use equation number 1. What is equation? This is the equation. Substitute the term. N is equal to c. C value 100 into e power k into t value 90, which is equal 100 into e power 90 into k. K value is what? 1 by 16 into log of 3.32. 60 how many times did we cancel? 32 are 33. That means e power 3 by 2 log of 3.32. We know that formula. P log A can be written as log A power 3. 100 into e power log of A power B. That means 3.32 whole power 3 by, which is equal 100 into, here e power log x. What is the value of e power log x? X. So e power log x. What is the value of x? 3.32 whole power 3 by 2. Use that one here. 100 into 3.32 whole power 3 by 2. Use your calculator for evaluation of this one. You will get the value as 604.9, which is approximately equal to 695. Like this, we are calculating the value of n. Now we are going to the another problem. So this radium decomposes at a rate proportional to the amount present. So here we given radium. So suppose radium quantity is n, is decomposes at a rate proportional to the amount present. Rate of change means dn by dt proportional to the amount present. dn by dt proportional to it. Decomposes means decreasing. Decreasing means this is called dn by dt is equal to minus kn. So this is negative constant means this is law of natural decay. By law of decay, what is the formula for this? N is equal to c into e power minus k. This one by using the given condition we have to calculate. Otherwise by using the given data also we have to calculate. Here see this. If 5% of the original amount disappears, 5% of the original amount disappears in 50 years. So original amount if does not known, in that's why let initial quantity as 100, that is n is equal to 100. Initial means what is the condition? At t is equal to 0, n is equal to 100. That means at t is equal to 0, how much quantity available? 100 quantity is available. 5% of the original amount disappears in 50 years. 5% is removed, but here we are using only how much quantity available. 5% disappear means in 100 5% removed. What is remaining? 95. Always we are taking how much amount present. So at t is equal to 50 years, n value 5% you have to remove. What is remaining? 95. Now what is our question? How much will be remain after 100 years? That means we have to calculate at t is equal to 100. What is the value of n? At t is equal to 100. What is the value of n? So see this. At t is equal to 0, n value 100. At t is equal to 50, n value 95. As time increasing, quantity is decreasing. That is called law of decay.
Either by using the given data, we have to frame law of decay, or by using the given sentence, we have to write this is law of decay or law of growth, or by using given data, we have to say that it is law of growth or decay. So it is law of decay. So let it be equation number 1. Now here say this C, K, two unknowns, T given two conditions. Use these two conditions for evaluation of C and K. After that, at T is equal to 100 here, we are calculating the value of N. So what is the equation number 1? N is equal C into e power minus K2. This is our equation 1. What is the first condition? At T is equal to 0, quantity is 100. 1 implies, substitute these two in this, 100 is equal C into e power minus K into 0. That implies 100 is equal e power K into 0, e power 0. Anything power 0 value is 1. So C is equal 100. Next condition, at T is equal to 50 years, N value is 95. Again from 1, substitute these two in N. 95 is equal C into e power minus K into T value 50. 95 is equal T value 100, e power minus 50. Okay. That 100 comes to the left hand side. 95 by 100 is equal e power minus 50. Okay. Exponential comes to this side. Logarithm. Log of 95 by 100 is equal minus 50. So K is equal minus 1 by 50 into how many times getting cancelled? 520s, 590s. Log of 19 by 20. This is the value of K. So by using two conditions, I evaluated two unknowns. Now we have to calculate at T is equal to 100 years N1. At T is equal to 100 years, from 1 implies N is equal T into e power K into T value 100. That is equal to T value 100, e power K value. What is the value of K? Minus 1 by 50. Minus 1 by 50 into log of 19 by 20 into 100. 52 times getting cancelled. 100 into e power minus 2 into log of 19 by 20. 100 into, which is in the form of b log a. B log a can be written as log of a power b. 100 into, which is in the form of e power log x. E power log x value is x. So this one is 19 by 20 power minus. Power minus 2 comes to denominator, changes as numerator as denominator, denominator as numerator. 20 by 19 whole, which is equal 100 into 20 by 19 into 20 by 19. Now we have to calculate this one, approximately I think so 90.25. Use calculator for this. Use calculator for this. You will get the value as 90.25, which is the answer of the given problem. Now I am going through one more problem. See this. If the population of a country doubles in 50 years, if the population of a country doubles in 50 years, in how many years will it be tripled? Here he does not mention the sentence that is related to law of growth or law of decay. In that way, by using given data, we are saying that it is law of growth problem or law of decay problem. So observe this. Here also he does not mention what is the quantity of the value. So here, for example, I am taking that let Let initial population is equal to 100. So what is that initial population? N value 100. That means at t is equal to 0, n value. Population of a country doubles in 50 years. So at t is equal to 50 years, doubles in 50 years. 100 double means 200. That means n value 200. What we have to evaluate? In how many years will it be triple? Triple means n value 300. So if n is equal to 300, we have to calculate time value t. So triple means 300. If n is equal to 300, what is the value of t? He is asking that one. How many years will it be triple? He asking that one. We will calculate this. Now say this. Here at t is equal to 0, n 100. At t is equal to 50, n 200. As time increases, quantity increasing. So this is called law of growth. So by law of growth, what is the value of n? N is equal to c into e power k. This is our formula. Now use first condition. What is first condition? At t is equal to 0, n value 100. Substitute these two values in this. Then this one changes as 1 implies 100 is equal to c into e power k into 0. 100 is equal to e power 0 value 1. So c is equal to 100. Now we are using second condition in that. What is the second condition? At t is equal to 50, n value 20. At t is equal to 50, n value 200. Then from 1 implies, what is 1? N is equal c into e power k into t value 50. That implies, already you know the value of c. What is c? 100 into e power 50k, which is equal, this 100 comes to the left hand side, 200 by 100 is equal e power 50k. So 200 by 100 means 2 is equal e power 50k. Exponential comes to this side, log 2 is equal 50k. 50 comes to the left hand side, k is equal 1 by 50 into log. So this is the value of k. So we evaluated two unknowns. What are the two unknowns? C and k. Now we are calculating the time. If n is equal to 300, then again use 1. 1 implies, what is the 1? N is equal, 300 is equal c into e power k. That implies 300 is equal c value 100, e power k value. What is the value of k? 1 by 50 into log 2 k to t. 100 comes to the left hand side, 300 by 100 is equal e power v log a can be written as, otherwise write this one as it is log 2 by 50 into t. That implies 300 by 100, 3. Exponential comes to the left hand side, log of it. Log 3 is equal log 2 by 50 into t. From this I want the value of t. What is the value of t? 50 into log 3 by log 2. This is here. So whatever value you are getting, that one is like this. Use a calculator for this. Use calculator. Use calculator for the value of this one. You will do that. Like this, we are evaluating the problem. So this is the last problem related to the law of growth of decay. A bacteria culture growing exponentially, that means it is increasing Growing exponentially means dn by dt is direct proportional to kn. Increasing state means dn by dt is equal c into e power k. Sorry, n is equal c into e power k. Now see the curve. Bacteria culture growing exponentially increases 200 to 500 grams. So 200 to 500 grams. So initial value given. Initial. What is initial? At t is equal to 0. Initial bacteria is 200. Increase it to 500 grams in 6 a.m. to period from 6 a.m. to 9. How many hours between 6 to 9? 3 hours. So at t is equal to 3 hours, n value is 500. Then what is our question? How many grams will be present at noon? So this one increasing from 6 a.m. to noon. What is the difference between 6 to noon? 6 hours difference. So at noon, how much of bacteria will be present in asking? So at t is equal to 6 hours, we have to calculate the value of n for this. So this is our equation 1. So if you are observing the given data also, you are saying that it is a log. See this, as time increases, quantity is also increasing. So this is called log growth. Now use first condition. Because of that, this one having two unknowns, we given two conditions. Use these two for two unknowns. What is first condition? At t is equal to 0, n is equal to 200. One implies n value 200, c into e power k value 0. That implies 200 is equal c into e power anything 0. E power 0 value is e power 0 value is 1. That implies c is equal to 200. I got one unknown. Now I am evaluating another unknown. So what is the second condition? At t is equal to 3 hours, n value 500. Again use equation 1. N value 500, c into e power k value, k into t value 3. 500 is equal c value 200 into e power 3k. 500 by 200 is equal e power 3. That implies 500 by 200 means 5 by 2 is equal e power 3. That implies exponential comes to the left hand side. Log of 5 by 2 is equal to 3k. From this, k is equal 1 by 3 into log of 5. So I got another unknown also. Now we are evaluating at t is equal to 6 hours. At t is equal to 6 hours, 1 implies n is equal c into e power k into 6. C value 200. E power k value 1 by 3 into log of 5 by 2. 1 by 3 into log of 5 by 2 into k into k value only I written. So k will not be this. K value this time into 6. 3 2 times getting cancelled, which is equal to 200 into e power 2 log of 5 by 2. 200 into, which is in the form of b log a. B log a can be written as log a power b. B log a can be written as log a. 200 into e power log x is x. We know this. E power log x value is 5 by 2 whole square. E power log x is there. This one is 5 by 2 whole. 200 into 5 by 2 into 5, which is equal 200 times 250 times. 5 5s are 50, 5s are 250, 255s are 1250 grams. So, at T is equal to 6 hours, N value is 1250 grams. So, like this, we are calculating the values. So, here our summary. What is our summary? In this session, we learned only law of growth or decay related problems. So these problems only we discuss in this session. So with this one, our topic differential equations of first order and first degree applications also come. In the next session, we will go through the another chapter 10.